Hey there, sixth graders. Since I'm not here for part of the day today, I wanted to make this video to make sure that we stay up with all the other class periods and keep moving along here in our rock unit. So we're going to use this video to kind of navigate through class today. You're going to kind of come back and forth to it a couple of times. So let's go ahead and get started with some class notes. If you need to, pause the video to be able to get to Google Classroom and open up your rock notes and get to the part of your document where we're ready to take some notes. So if you need to, go ahead, pause the video now. Okay, so let me get this a little smaller here. Where we left off before break was talking about sedimentary rocks, and we were talking about the three subgroups of sedimentary rocks, and we got through two of them, clastic and organic. We'll spend time reviewing them when I'm in class together. I don't want to spend time on the video doing that now. Let's just kind of plug through and get some of the notes done. If you are absent at all the week before break, and this is not the last thing you have down on your notes, or when you open up that doc, it's completely blank because you've been out, you need to make sure you come to advisory Thursday or Friday this week to come make up the notes. That is your responsibility. You miss class, you have to get those notes. So if this is not the last thing you have, you're missing notes, you need to come see me in advisory on Thursday or Friday to get these notes. Okay? All right, so we left off. We did clastic sedimentary rocks, which are sedimentary rocks made of broken down fragments of other rocks and minerals. We talked about organic sedimentary rocks, where the sediment is made out of organic material. The rock isn't alive, right? But the material that makes up the rock is coming from things that were once living. The last one, oops. There we go, is chemical sedimentary rocks. Okay. Feel a little glitchy here. So go ahead and make a new main bullet here, chemical sedimentary rocks. All right, so sedimentary rocks, all formed by sediments, even these chemical sedimentary rocks. So what happens here? Well, this is very much like what we learned with minerals and the formation of minerals. If you remember, one way minerals form is when the compounds that make up the elements for the minerals are dissolved in water. Well, this is very similar to that, except now it's the actual mineral is broken down and dissolved in water. So it's still made of sediments, mineral sediments, but the sediments are dissolved in water. So technically, the definition here is when sedimentary rocks form from precipitation of minerals from water. And what that just means is that we have minerals that are dissolved in water, and when they leave that water, and it can happen a couple of different ways, but when they leave that water, the rock is formed. Okay? So the water goes away and the rock is formed. There's a couple of different ways that this can happen. So bullet. The way that we're familiar with, because of our mineral unit, they call them evaporates. You're not going to need to know that term in sixth grade, okay? But I might as well tell you what it is, because that's what they are. But you don't need to know this for a test or anything in terms of the evaporates. You do need to know what a chemical sedimentary rock is, but you don't specifically need to know the evaporates. But evaporates are when the water evaporates away. And so then now you just have the sediment there. And what happens then with the sediment is the same exact formation of when you have sediment for clastic rocks or when you have sediment for organic rocks. We're going to talk about that process here today as well. But the water goes away, okay? And in this case, it evaporates. The second way that you get these dissolved minerals to be by themselves away from the water is when you have the temperature of the water increase or the acidity of the water increase. And what that does is it leaves the sediment to no longer be dissolved. Okay, and that has to do with other science properties in terms of temperature of substances and the rate at which they're able to be soluble, meaning that they can dissolve things. I'm which we don't need to get into now, but just know that when temperature increases or acidity increases, it's harder for materials to stay dissolved in water. And so then they just settle out. And sometimes they just settle at the bottom of the water. The water doesn't actually have to go away. It can, but it doesn't have to. And now you have sediments at the bottom of the water, and the same process that then goes on to form clastic sedimentary rocks and organic sedimentary rocks evaporates would happen because now you have sediment. Okay. Chemical sedimentary rocks, some of the most common ways that we think about them forming are limestone caves, where you have the dripping of the material in these limestone caves. If you've ever been to one, that's a great example of a chemical sedimentary rock. Okay. All right. So those are our three classes of rock. And as I've mentioned here today, no matter what, and I think it was in our notes on one of the first slides for sedimentary rocks, no matter what, you end up having sediment. And the sediment then goes through basically the same process, no matter whether it's clastic, organic, or chemical. The type of sediment is different, and maybe how the sediment gets there, like organic material, it's living things that have died and decomposed. Chemical rocks, you have stuff that's dissolved in water and somehow has to either settle out and not become dissolved, or the water has to go away and evaporate. But eventually you have sediment. And so what are the steps then for sedimentary rock formation? All right. So here's what you're going to do. Let me give you the directions. And then you're going to go ahead and work on this, and you can just do it right here in your seat. This shouldn't take too long, and you shouldn't have to ask people for help for this. This should be pretty self-explanatory. In Google Classroom, I have a Google Draw doc. And on the doc, it looks like this, but there's no words in it. Okay, it's just the shapes. I'm going to get out of there so that you don't see it. Now, your job is to fill it in. So on the top, the blue, you're going to go through and you're going to use the book. And on the book, you're going to go through and you're going to use pages. I think it's 151. I don't have the book with me here at home, but I think it's 151 or 152. It's the beginning of the sedimentary rocks section. So I'm close to the page number. So just kind of look. And it's going to talk about how sedimentary rocks form. And there are 5 steps. You're going to put those steps in order on that flow chart from left to right. Once you have those 5 steps in, and each of those steps is just one word, okay? Each of those steps are just one word. Once you have that in, there is a box below or a bubble below, and that's for the definition of that step, of that term. All right, so let me give you an easy one. Erosion's one of the steps. So that's going to be in one of the boxes. Underneath that blue box that says erosion, you're going to give me the definition of erosion. And all that is from the book. Okay, somewhere around 151, 152. Okay? Now, we're not done with this. Okay, this is just one step of the notes. So go ahead and pause the video. Go get a book. Work on the flow chart that's in Google Classroom. And once you're done with it, come back to this video. All right? Okay, pause it now. Okay. All right. Let's go through and let's talk about characteristics next. We'll come back to what you did on the flow chart when I'm there, okay? Because I want to talk about it with you. All right, characteristics. Go ahead and make a new bullet there for characteristics. Okay, we're going to go through this slide. And then you're going to go and with your group, go over and work onto the prediction lab. So I'll explain that here in a second. Let's do this slide. Okay, so because sedimentary rocks basically form the same way, and the difference between the 3 subgroups of clastic, chemical, and organic is just the different types of sediment, we don't see characteristics specific to just their subgroups, which we did for igneous rocks. We had a list of intrusive igneous rock characteristics and a list of extrusive igneous rock characteristics. We don't see that for this. Okay. These are basically all three subgroups can have these characteristics. One of them is that we usually see them formed in layers. And based off of how they form, those 5 steps that you just went through on that flow chart, that should be logical. That should make sense that they form in layers. And you usually can see layers. Does that mean every sedimentary rock it's easy to see layers? No, of course. In fact, this whole list of characteristics, it doesn't mean that every sedimentary rock have these characteristics. These are just some of the common ones. The more of these characteristics you see in a sedimentary rock, the more likely you're looking at a sedimentary rock. Because sedimentary rocks form from sediments, and sediments can be different sizes, we now have different textures of the rock. Okay? And so some sedimentary rocks can be coarse grained because they have large sediments. So that would be a rough, sandy like texture. But on the same hand, you might have a sedimentary rock that forms with tiny sediments. And because of that, that sedimentary rock might end up having a fine grained texture. And so it's going to be a lot smoother. So some sedimentary rocks can be rough, some can be smooth. So that doesn't necessarily help us with identification of sedimentary rocks, right? Because they basically could have any texture. It all depends on the sediment size. Now, it does help with identification of the sedimentary rock because certain sedimentary rocks like sandstone have a sandy texture and other ones like shale have a fine-grained texture. And so you know that if it's a rough texture, can't be shale, okay? Based on the process of how sedimentary rocks form, most sedimentary rocks are pretty soft. Now remember, we're talking about a soft rock, not soft in general, right? I'm not going to use a rock for a pillow if I don't have to. But in comparison to the other sedimentary rocks, in comparison to the other types of rocks, igneous and metamorphic, these are a lot softer. They're more easily able to break as well. More easily weathered and broken down. Some sedimentary rocks can have holes in them because the sediment size is so big that there's gaps in between the sediments because they don't fit together very well because they're so big. And so there can be holes. We call that a porous texture or porous. And yes, that was a same characteristic from igneous rocks, for extrusive igneous rocks. And we're going to see that sometimes rocks share a characteristic, which is what makes this difficult. And then obviously, if we have organic sedimentary rocks, we can have sedimentary rocks that have fossils in it, right? And fossils can be imprints, where it's not the actual material, like an imprint of a leaf, or you might actually have the material in it, like a tooth or a bone or a shell. Sedimentary rocks can contain fossils. I think that's it. Yeah. Okay. So let's talk about what you're going to do for the rest of class here, because this is the end of the video. Pause it if you need to type, because I'm going to expand my screen here. Okay. For the rest of class, there are 2 things that you can go ahead and work on. First thing is you're going to do the prediction lab for sedimentary rocks. You're going to use this last slide, the characteristics. You're going to go to your lab table. You're going to take out your rocks. Do the best you can with the numbers since I'm not there. Go through and try to figure out which 4 rocks are sedimentary rocks. Try to guess their subgroups. It's not as easy with as intrusive and extrusive because the characteristics are not specific to the group, right? It's not like, oh, if it has layers, that means it has to be clastic, okay? So just do your best. It's just kind of a guess at this point. And then your reason. And your reason is a characteristic. Which characteristic did you see that made you think, okay, this might be a sedimentary rock? Remember, these are predictions. You're just making guesses. Okay? You're not getting graded for accuracy on this. If you don't have one of these sheets, okay? If you don't have one of these sheets, just work with your partners in your table right now to go through the process, talking, be in the discussion with them. And then obviously when I come back, I'll get you the sheet and you can catch up when we do metamorphic rock later in the week. Okay? All right, so that's the first thing. Okay? Now, if you're done and you got to wait a couple minutes for your group members because it took them a little bit longer to do that flow chart, the drawing, the Google Draw, just chill out for a minute or two here and wait for them. Maybe you can go over and get the rock set up. Okay? And then if you finish the prediction lab and there's still time left over in class, right? You guys have the igneous rock worksheet that you can be working on with the book. Up on my desk is the sedimentary rock worksheet that you can be working on. If you finish both of those and there's still class time left, work on something independently that's school appropriate at your seat. Okay? And you can use it to just get some other work done. So it's prediction lab. And then if there's time, igneous rock worksheet. And if you finish that, just hold on to it. Then you can grab the sedimentary rock worksheet that's on my desk and work on that. And if you finish all of that, something school appropriate on your own until class ends. And I'll see you guys hopefully tomorrow. All right. Have a good day.